Hello, everyone. I'm loving that big transit energy we just had on that last panel. Hoping we can continue it on. So as Josipa said, my name is Jesta. I'm with Clean Energy Canada. We are a program based out of the Centre for Dialogue at Simon Fraser University, where we're working to transition Canada to a clean energy economy. Something that we released earlier in 2019 that's really relevant for the group gathered here today is a report called Will Canada Miss the Bus? And that explored the current use of electric buses at home and around the world and the opportunities that they present for Canadian manufacturers, transit operators, and of course the riders. We're also involved in the Global Drive to Zero initiative, which is designed to catalyze the growth and adoption of zero and near zero emission medium and heavy duty vehicles, of which buses are a big part of that. And so, suffice to say, we're really on board with the shift to electrified transit, pun intended, and that's why I was pleased to be asked to be the moderator for our panel, which is titled Going Forward by Looking Back Field Data from Transit and Transportation Electrification. Now, perhaps you were super keen and you read the panel description online. Maybe you have no idea what this panel is going to be about. If it's the latter, I've got a little description for you. I think there are going to be a lot of synergies and overlaps with the last panel, and it won't be repetitive, though. So we know that with any new technology, the unexpected or the unplanned for is really to be expected. And so with our panelists, we're going to explore the ongoing outcomes of transit experiences on the road with a variety of electric bus technologies. We'll hear from our panelists about the benefits, the pitfalls, and the workaround solutions that they're innovating to overcome the early stage growing pains for fleet electrification. The goal is that at the end of this session, you're going to walk away with some recommendations and best practices for transit systems here in Canada based on our panelists' real-time and historical experiences. Of course, as some folks earlier have said, transit agencies, one, that's all you know. So it's a little bit of, it's not so much apples to apples, but I think that you'll walk away with some inspiration and some food for thought. So I'm going to join or ask my panelists who are just getting to know each other over there, Pierre, Mike, and Ray, come on up. You all know Mike, so that's great. How the next 65 to 70 minutes are going to unfold. It's going to be pretty similar to how the sessions previously unfolded. However, I'm going to give a bit of more of an introduction, a bio for each of our panelists, and then they'll do a little presentation, and then I'll pose a few questions, and then we are going to have time for all of you, and we will get to those questions that were posed. We're actually, sadly, one of our panelists wasn't able to make it, so that actually maybe gives us a little bit of time for the questions. So with that, I'm going to introduce Ray Homestead. Ray, I hope I got your name right. You told me how to pronounce it last time. Perfect. So Ray is the Executive Director of Research Partnerships and Innovation at Red River College. Ray has led the establishment and growth of the applied research enterprise at Red River College since 2004, when he was appointed Director of Applied Research and Commercialization, and in 2016 he took over his current role as the college's Executive Director, Partnerships and Innovation. During his tenure, a robust research enterprise has evolved, leading to some $85 million in capital investments for research infrastructure, annual research revenue of some $6 million, Canadian and international research partnerships, a consistent top 10 Canadian research college ranking, the prestigious Natural Sciences and Engineering Research Council College Synergy Award, and the Colleges and Institutes Canada Gold Leadership Excellence Award. Ray holds a BSc and an MSc in Agricultural Engineering from University of Winnipeg and is an alumni of the Governor-General's Canadian Leadership Conference. And with that, I'll turn it over to Ray.
Thanks, Jess. You could have just said I'm a tractor guy. I started out designing tractors, so that's my first job. So I'm just have about 8 or 9 slides here. Just want to run through to give you a quick overview of what we've been doing at the college with respect to applied research in the electric battery transit bus and other vehicle technologies, and then we'll have the Q&A afterwards, I guess, with the rest of the panel. So we're the second largest educational institute in Manitoba, a large institute of applied learning. We have multiple programs ranging from trades to technologies to a couple of degrees in nursing as well as construction management, multiple campuses across the province. We've been at this now for about 15 years, and clean, green, and extreme technologies are one of our focus areas, and that's where the bus technology fits in. So just a couple of initiatives that we've had over the years. Back about 6 or 7 years ago, we were funded by the province to establish what we called EV Tech, or the Electric Vehicle Technology and Education Center, which had a mandate for applied research, education, and training. And then we were fortunate to get an NSERC Innovation Enhancement Grant. So this is a college-specific grant. It's a 5-year research grant to do a research program. And ours is focused on vehicle technology and energy, especially the use of renewables and sustainable energy. A lot of it's on-off-highway vehicle technology. You may or may not know, in Manitoba, we're fortunate to have 5 heavy vehicle OEMs. Bueller Versatile, who does the farm machinery tractors primarily. MacDon Industries, now owned by Linamar. They do harvesting equipment. Of course, New Flyer and Motor Coach Industries on the intra-city and intercity buses, and then Fort Garry Fire Trucks, which is Canada's largest fire truck manufacturer. So the sector is about $2 billion in sales a year, of which $1 billion are exports, and about 6,000 employees. So it's very important. And as you may or may not be aware, in the college community, we really try to react to economic development needs of the community. So that's one of the reasons we're into this sector as well. And we have several unique facilities on the vehicle technology side, which I will go into more later on. And here we are. So Motive Lab is unique in Western Canada. It's a driving climatic chamber with integrated 3-axle chassis dynamometer. It's rated for 1,000 horsepower, and here we go. The chamber is big enough for a bus. We've just finished commissioning on the chamber, so we can do -40 to +50 year-round under full load, which in our case is 650 horsepower continuous for 20 minutes. We're just finishing up some Department of Labor requirements, so we should be fully operational by the end of this month. We actually changed the braking system in chassis dynos to replace AC. We used AC motors to replace the braking system, so therefore we can also simulate slopes in the chamber. So this is unique in Western Canada. The nearest chamber is in Argonne National Labs in Chicago. With the changes we made to the dynamometer, we're able to actually generate power, and just to give you or electricity. And so just to give you a sense of the capacity of the chamber, which was designed by Lois Engineering out of Toronto. Under full load operating in extreme temperature conditions, we are about 20 to 25% of the entire load of the campus. So we're not going to be running during the day probably if we ever have that sort of temperature requirement. We'll be running more at night to avoid the peak loading. And we can actually power the building that we're in with the electricity we're generating, and the electricity we can't use, we have a 2 million BTU toaster, a resistor bank, which could, if it was a barbecue, you could cook 100,000 quarter pounders at the same time. So everything is big in the facility. It's about a $10.5 million investment by CFI Research Manitoba, the federal strategic infrastructure program, as well as the province and ourselves. You'll see this better when you get the presentation afterwards, but we've been involved with vehicle technology since about 04, 05, going back to helping Motor Coach meet some US EPA emission requirements. Basically, we had a project was here's a bus, here's a transmission, here's an engine, make it all work together to meet USA EPA requirements, which we did within 6 months. So that was a good fortunate timing, but it worked out. We've done a lot of vehicle technology demonstrations over the years, both in the automotive and heavy vehicle side. So, for example, we did some winter testing with the prototype for the Olympics with the Ballard fuel cell, and the New Flyer bus. We worked on the ICE bus, which came up from San Diego. We did some winter testing on that, and then we were involved for many years on the electric battery bus. So the electric battery transit bus project started out in 2011 as a 3-year, $3 million project with 5 partners, including Mitsubishi Heavy from Japan, the province, Manitoba Hydro, New Flyer, and ourselves. We're using lithium-ion batteries provided by Mitsubishi as part of the integration, and our role in that first phase was basically helping to put the battery packs back together because they had to be flown over for timing considerations for the project, and then we helped Manitoba Hydro a bit with the charging side of things. Then that was expanded with a proposal that New Flyer put forward to SDTC, and it became a 5-year, 5-bus, $10 million project. And 4 of those buses, which were considered pre-production models, actually went into fare service with the City of Winnipeg through Winnipeg Transit, and they're operated on Route 20, which just coincidentally was named Watt Street route. We didn't realize that when the route was picked, but it was one of the longest routes in the city. And if you're at the airport, you'll notice there's still the overhead chargers there at just to the west of the arrivals area. And this was, very good for the college as well as the partners that we worked with. So right now we have an NRCan-funded electric battery repurposing project. So we've received some used batteries that came from New Flyer, and we're going to be putting them into a level 3 DC fast charging system at the college. So that project is under development right now, and we'll be also working on developing curriculum program development for safe handling of these high voltage battery systems. Okay. Thank you.
Thanks, Ray. You even gave us a minute to spare. So we had some of the academic perspective. Now I'm going to welcome Pierre Vizek to the stage, and we'll probably share more of an operator and perspective, and also touch on the rider experience and the economy. Pierre has worked in the world of public transit for over 15 years, always passionate about the challenges of sustainable mobility. He is today an internationally recognized expert of Transdev Group in the field of electric and autonomous vehicles, where he's the general manager of maintenance and procurement. Pierre has held several strategic positions within Transdev, which has enabled the group to position itself today as a world leader in the operation of electric vehicles. Pierre.
All right, next is here. Sorry, guys. Good day. Just before I start, used to live in Australia for a while, so if you get some Australian words in my English, just raise your hand, because I discovered some of my colleagues don't understand me. What I want, first of all, I don't want to paraphrase a lot of stuff that I heard since I arrived at midday. Clearly, there is a very, very good view on the electromobility. So I'm going to try to give you a point of view as an operator that is currently operating a bit more than 750 electric buses, including this is a Europe operation where we have more than 120 buses in one operation. So it's kind of insight of how we've done that and what are the key messages. First thing first, what's the future of mobility? Because there is a point about that. It's we describe it with the acronym of PACE. Mobility in the future will be personalized. This is something everybody has in mind. We want our own mobility. Our passengers want to be considered as unique. It will be autonomous. That's the subject for tomorrow. I will be there. We'll be connected, and it will be electric. Connected in a way that, can you imagine putting an electric bus on the road and not having any app or any brand new system that fits this new electromobility? This is a slide I've made in 2009. At that time, I thought I was smart. I was not. What you have on the left was a conventional diesel CNG in the start of the hybrid that we start operating in 2009 in Europe. The idea was the same as everybody around the room. We knew that electricity was around the corner. So electricity was on the right. Not exactly on the right, by the way, because there is an electricity transit system called trolleybuses that exists for more than 120 years. That said, it has this downside. We all know about it, and not a lot of cities want to install this kind of trolley and an overline charging system. So we knew that we were going to the new technology of battery buses. And in between, we had the idea, okay, I'm politically or technically, I want to reduce my greenhouse effect. I'm going to purchase some hybrid. And the trend here, you can see, was about the life of the hybrid. So let's say 15 to 20 years, as we hear the investment discussion. Reality is it has been way faster than that. And start of 2013, 2014, just before I left for Australia, we were already working deeply on electric buses, as you all know. And by the way, I would just want to say that in 2009, 2010, I was looking at America. We were starting to operate early the 2010 Proterra bus in Foothill Transit, and I was so proud of my colleague over there. I wanted to see these buses that was able to charge at the end of the line. At that time, was not existing in Europe. So, how many progress we've done in those years? That's incredible. What about the technology? You've seen a lot of pictures. I can say I've tried it all. Not everything is working well, and it has its good side and bad side. You know that, and there was a question about the weight. The question about overnight charging or opportunity charging, which has been discussed since this morning, is a very good question. The real point is that we need to think, as an operator, we need to think about the passenger perspective. My passenger wants to go to a point A to a point B without any change of bus because we run out of battery, right? So basically, and they want to have a bus. At the beginning of 2010, the first buses we experiment were about 42, 43 passengers for a full-length bus. At the same time, in Europe, we're about 85 to 90 passengers on conventional buses. So we got that rule, which is not valid anymore, of 1 to 4. For one diesel, you needed 2 buses to cover the range, and you needed 2 other buses to cover the passenger capacity, which means that for 1 diesel buses, you needed 4 electric buses, 4 drivers. I mean, I don't do the math, but you have an idea. There is a discussion about slow charging, fast charging, combination of the both. The best idea is how many people do you need to carry from point A to point B today or tomorrow? Because this is a key point. If your buses are half empty, well, a battery bus overnight charging would be more than enough. But if your bus is full, and someone was talking about BRT, that's quite difficult to put an overnight charging bus, right? Because you will reduce by half the capacity, and there will be a problem of number of buses on the road. So that's a technology. Pantograph, I've seen picture of pantograph, I've seen picture of reverse pantograph, I've seen picture of induction. We tested induction, we tested plugins. Everything works. Has to be reliable now, and it is reliable more or less in the whole world. In Transdev, we try to find a way to design a network on electricity, and that's something I want to emphasize. Changing to electricity is not switching a diesel bus to an electric bus. I think everybody got that. But how do you do that? It's very complicated, and it has been said before, every city will have its own result because there is no recipe. The only recipe you have is that you need to put your must-have, your nice-to-have, and your, or if possible, I would like that, at the entry point. You put that on systems, and we've designed an e-bus living lab, which it's a kind of expert meeting where we group together PTA, we group together technical experts from the world, including scheduling people. Let's not forget that sometimes by scheduling you gain bus. If you gain bus in the bus flow, you gain money. It's part of the balance. And the idea was, let's say, do I want the same timetable tomorrow? Or do I want to adjust my timetable to suit electricity? We put that in the system, we'll calculate, and we obtain a result. Believe me, most of the time the first result is really bad. Really bad is twice the price of the existing, thrice the price of the existing. And then you adjust. You say, okay, I'm going to put an overnight charging there. I'm going to put a specific charging station here. More or less, I try to join with a railway, for example, because they already have electricity, which reduce the capex. And I try to do my best, but as you may know, for now, it's still more expensive than diesel. So that's not the question. The question is greenhouse effect and how we solve it. So it's an iterative process. It's a virtuous circle. And sometimes we failed on starting some stuff that was not perfect, but that's how we learn. No, we're very good. I mean, we are very good. We work hard to try to find the best solution and to convince our PTA on what is the best solution for them. Something about the batteries. There is what we call the C factor. It has nothing to do with a TV show. It's less fun than that. It's the time a battery takes to charge itself. So you all have a cell phone, right? I mean, you put a fast charger, either you have a Samsung, an iPhone, whatever, and then the system will tell you how many minutes it requires to charge. If your phone is empty and you plug in and the system say 1 hour, then you have a phone that accepts a 1C charge. It's not related to the charger. It's related to the battery and the charger. If you have a wonderful charger but you don't have the battery accepting a fast charging, then you will have a problem. You see here the split, and for the one who have worked on the design network, on the electricity, you know all the split between power battery and energy battery, which is still valid of today, but is slightly going to change in the next years. Energy battery is a battery you charge overnight. You need time to charge them. Power batteries, the batteries that accept a fast charging, you see till 2C, 2.5C, that means that, let's say, you want to charge 30 kilowatt hour, it will require half, 20 minutes, 15 minutes, 10 minutes, even less than that. So the idea is, what will be the next technologies? There is a technological barrier now on how much energy you can put on a kilogram of battery. That is going to change over the next 10 years. Who knows what will be next? No one, except that you can read a lot of documents, technological documents, and you can expect what will be the future. And I will end up with this one. This is a calculation done on a scheduling system on where to put a fast charging system on a line. It's not really visible, but there is a red line. Well, don't go under the red line, because otherwise you can't go back to the depot. So the idea when you design your network is trying to be sure that you charge early enough, of course. That makes sense, right? But also that you come back to the depot. It's good to be at the terminal, but if you have to plug in the bus at the terminal and you have nothing to plug in, there will be a problem. Last but not least, in North America, may I say, as I work in many countries, great stability. And a positive sign that has not been said, I just want to say, with electric buses, there is far less impact on neighborhood. So when we park far away from people, far away from houses or buses, because it's diesel, it's fuming, it's making noise, why not trying to park some of our buses very close to the terminal, very close to the city center? Why not? That reduces deadhead, that reduces pull-in, that reduces pull-out, that's cost saving. And I thank you very much.
Thanks, Pierre. It's great to get that international perspective. You all know him, you love him. Mike from Toronto Transit Commission. Mike, did you want to add anything with the presentation? From what you touched on earlier? You're good? Yeah, I got a new presentation. You got a new one? Sweet, okay. So come on up, Mike McCass, if you forgot. He's the Senior Manager of Vehicle Engineering at the Toronto Transit Commission.
Hello, everyone, again. I think this presentation will be a little more exciting than the last one, just because we actually have data now. We have buses in service, and I think everybody's really anxious to see numbers. I'll skip this slide because I went through this last time. Let's get right into the meat and potatoes. You know about the program. It's 3 different buses. The data I'm presenting to you today is really only focused on the new Flyer bus because that's all we have in service at this moment. Again, to reiterate, the Proterra should probably be going in service in early October. And the BYD is arriving in October, and hopefully we'll commission it and get it in service for sometime in November. So here's our experience to date. So like I said, we launched on June 3rd. First bus went to service. We commissioned the second bus shortly after that. That bus was dedicated to training operators. So I didn't want to share data for June because it was essentially for one bus. Mind you, July is only for 2 buses in service. However, we put some significant mileage in comparison to our first month. And just to take a moment to talk about our deployment strategy, we really picked 35 Jane as our first route. Based on the duty cycle, it's probably one of the most toughest duty cycles of all the routes we have out of our air road division. Has heavy loading, significant grades for it to climb up in the valley there by Eglinton and Jane. And it had a plethora of short-range routes, or we call swing routes, that are under 100 kilometers or under 85 kilometers, that would give us the flexibility of deploying buses in the morning service and then again in the afternoon service. And so for the month of July, really what we did was we concentrated on AM and PM swings. We started off early in the month with only deploying it in the morning, and then we started deploying in the morning, bringing it back, charging it midday, even though it wasn't necessary. We want to get our operators in the routine of plugging in buses. Because that'll play into our overall vision in the future of having a system that'll actually charge the buses and control that, but you need to have them plugged into that network or that system. So anyways, focusing on AM and PM swings of 85 kilometers or less and weekdays only. We stayed away from weekends for the month of July. We accumulated total mileage between those two buses, and it was predominantly the first bus that accumulated most of this mileage, but 6,300 kilometers. I won't get into nitty-gritty of energy consumed, but the average energy consumption was 1.42 kilowatts, and that's actually really good. From Qtrix modeling and from a test route that we devised as part of our commissioning plan with loading the bus with 12,000 pounds and running it through a rigorous route that's duty cycles comparable to the Altoona test as far as door cycles and speeds between stops. Anyway, we were getting about 1.55 in those tests. Qtrix, I think, modeling was around 1.52. So we're averaging 1.42. That's with the same operator or same two operators on the same two buses. Energy costs for the month of July, I was surprised. They were 19 cents per kilowatt. I was expecting less, and I called Toronto Hydro and said, hey, what the heck? Why so much money? And they explained to me that our global adjustment charges for that month were 13 cents. So it was a 13-cent premium. It's the highest month of the year so far. Typically, historically, it's been the summer months that you get hit with that GA charge. And typically, the rest of the months are averaging around 6 to 7 cents premium. So I expect those costs to come down as far as the overall average for the year. But anyway, our operating cost for the month was 27 cents per kilometer, which is higher than I would expect. I was hoping a little bit less than that. But in comparison to a hybrid, hybrids would be anywhere between 40 to 45 cents per kilometer. A clean diesel would be anywhere between 50 and 55, so it's pretty good. So just touching on the month of August, we had 7 buses in service, all flyers. At that point, we now opened it up to multiple routes. We picked 13 routes where we selected different runs. Again, AM, PM swings, but we also did regular runs that are under 200 kilometers. We have quite a few runs that run during the weekends that are around between 180 to 195 kilometers, which is that sweet spot where we're trying to keep on that 200 kilometer range, even though we feel we might have a little bit more, but right now let's just focus on 200 or less. So for the month of August, we put on 26,000 and change kilometers. The average energy consumption was 1.55. It's a lot higher than the first month. So I think part of this really is just different operators now that are driving the bus aren't really used to it, may not take advantage of regen. And there was a lot of testing in between here with commissioning chargers that we were using energy. And I didn't have time to really segregate that data to really focus on what energy was used to charge the buses. We're just not there yet. That takes time to crunch those numbers, and I just didn't have that kind of time. And I haven't gotten my electricity bill, but I'm anticipating that's going to be less than the month of July. So just some quick, I sliced and diced some of the data that we were getting. And again, this is for the same bus on the same route for the month of July, same operator for the most part. And again, some of these assumptions or some of these trends, I think they're pretty obvious. I think we all assume that these would be the trends. But again, when you look at the impact of temperature on energy consumption, yes, as the temperature increases, as HVAC comes on, has to work harder, yeah, you're using more energy. And as you get into colder temps, yeah, there might be instances where you use some electric heat in the morning when that bus is pulling out, and you have days where you're around 12, 13 degrees. And so you start seeing that energy creep up on the left side of that chart. And I think as we start now moving into winter operations in a couple of months, I think we'll populate this chart and you'll see more data that will define that curve, which will have peaks on either end, where if you have extreme cold, you're going to use a lot of energy. If you have extreme heat, again, you'll be using a lot of energy, and you have a sweet spot somewhere in between in that 22, 23 degree range where you're not really using a lot of those HVAC systems, and the bus runs very efficiently. Looking at speed, this is one that surprised me, but I've been surprised this even with hybrids. I think years ago I was always told that, hey, hybrids are perfect for stop-and-go service, and the lower the operating speed, the more efficient that bus is. In actuality, we're seeing the opposite. It seems that higher speeds, we're getting better efficiency. I think part of it is just maybe those higher speeds, you get more regenerative braking, and therefore you're recovering some of that energy. And I think the same thing applies for hybrids. We are seeing this on our hybrid fleet. I've talked to other agencies, Boston in particular, who is seeing the same trend. So it kind of throws out what we thought was, applying this to low-speed service. Again, the correlation, a lot of this, it's just a lot of data. Correlation factors aren't very good at the moment. As we get more data and more buses, hopefully those numbers will improve. But I think the trends are pretty reasonable. Maybe the numbers themselves, you probably couldn't predict the value from this data just yet, but I think the trends make sense. And so when you look at time of day, you get these peaks. Typically in the afternoon, we see more energy usage in the afternoon. I think this is really a combination of various factors. Loading in particular, you get peak loading in the afternoon, and you tend to carry more passengers in afternoon service than morning service. Temperatures in the summertime are hotter, so again, your HVAC's working harder. So again, just trends that we're seeing, just observations that might be of interest. But the key thing here is there's a lot of factors that go into the energy. And when people talk, what's the range of your bus? Nobody knows. You have to try it. Again, it's what I said earlier in the previous panel. You got to get a bus and try it for yourself and see how it works in your service and what kind of trends you see, because there's so many factors that go into understanding what the range is and temperatures and duty cycles and loading, and the list goes on. So there was questions about electric heat. We actually did an experiment where we forced electric heat on for a day, back-to-back days. So on a typical day on 35G run, we're running about 1.45 kilowatts per kilometer. The traction motor is the bulk of that energy being used, which makes sense. And then you have your high voltage accessories, which was your HVAC, which was about 23%. And these are days where we're hovering in the high 20s to low 30s in temperature in degrees Celsius. So with that same bus, the following day with your heat on, where we forced it on, our consumption doubled. So this is no different than what we are hearing from properties in Europe. In the U.S., not so much, because the deployments are concentrated in the southern states where they don't really have issues with heat, or they have it only a couple of days of the year. With us, it's a problem. And, I'll be the first one to confess, we equipped all our buses with diesel-fired heaters. I mean, it's a necessity. At this point, with the technology and with our approach for a depot-charged bus, long range, you have no choice but put diesel-fired heaters. I think in the long term, we're going to look at changing set points for our HVAC system. We've used the same set points in our bus spec for years and years and years. I'm not sure if anybody's actually tried pushing the limits to see what our customers would tolerate as far as cold temperatures and hot temperatures on the bus. It's something that we're willing to try and see if we can squeeze out some more efficiency from these buses. But in the meantime, we protected ourselves. We didn't want to take any risks. So we have diesel-fired heaters, and it's much easier down the road if we find a solution to this to turn them off than to have to integrate them and design them into the bus after the fact. Just another lesson learned for us. Of course, everybody wants to maximize range. We want these buses to stay out there the longest and get the most range possible. One of the things that we were playing with was the idea of, well, we know that battery manufacturers won't let you charge to 100% or deplete to zero, and you're somewhere in between in that 10 to 20% or 10 upper, 10 lower. So in the case of our bus, we were told that the maximum we could go is about 94%. But at 94%, you don't have any regen because you have no space in that battery to take a charge. So what does that mean for us? Well, for us, really, by the time regen kicks in at 90%, you're looking at about 11 kilometers or 26 minutes of service that you have no regenerative braking. Well, what that means for us, we had two instances where we had smoking brakes because the operator took the bus, he took the bus into service, deadheaded it. The deadhead distance was less than 11 kilometers. Passengers come on board, he starts going on the brakes, and they overheat, smoking. He calls it in, and we realized, okay, we can't do this. We got to forfeit those 11 kilometers, and we want that bus to leave the depot from the minute it leaves with full regenerative braking, so no difference to the operator. So that's a lesson learned. I've talked to other agencies. They aren't aware of this. They're starting to look at it now. With us, it's maybe the route that we were on where it gets heavy loading right from the first stop, where we experienced this in two occasions. We had these buses running for several days where this never happened, and all of a sudden we had one day out of the blue where this happened. And from looking at, we have all our buses equipped with telematics, started looking at some data, and we realized, oh, there's no regen coming on. Okay, we got to correct this. Lessons learned. Who plugs in the charger? That was a huge question. People were asking, like, well, who's going to plug in the charger? We have to pay people more money for it. So we brought all our stakeholders to the table and tried to figure what's the strategy here? What are we going to do? And really what our recommendation from our HR department was everybody plugs in the bus. Just train everybody from day one. If you're driving that bus and you're parking it next to a charger, the expectation is you plug it in. And you're just plugging it in. You're not fueling the bus. You're not charging the bus. You're plugging it in. And it's worked out really well. Everybody's plugging the bus. Yeah, there's been some mistakes with following the sequence to initiate a charge event, and we're working through that with training. But for the most part, everybody's plugging it in from day one, and that's going to help us in the long term when we introduce our smart charging system, where now you plug in a bus, the charging event won't start for a couple hours because it's programmed, but at least the bus is ready. It's connected to the grid. And lastly, I touched on this before, but employee engagement is really important. I think the success of our projects really a testament to how much effort we put in employee engagement. We were communicating with our employees from day one with posters of, hey, here's what's coming. Here are the benefits. Where e-buses are coming. We did a demonstration week in April of last year where we invited all 3 OEMs to bring a demo bus, and we took that bus and took it to all of our 7 divisions and allowed people, operators, maintainers, come on board, ask questions to the OEM, ask questions to the TTC e-bus team on the project and what we're going to do, what's the expectations and schedule and things of that nature. And also what we did with the 3 divisions that are actually going to accept the buses, we actually got the buses put on hoists, got the technicians to go underneath, look at the underbody of the bus, ask technical questions to representatives from the 3 OEMs. And I think that really helped. And what we did is we collected information. What are the concerns? What do people want to see? What are they afraid of? So that we can kind of control those messages and try to satisfy and reassure them that everything's going to be okay. Other things that we did, we shared drawings from consoles when we were working with OEMs and trying to work through the design of the consoles and where we want switches and the placement of them. We asked our drivers, we talked to our joint health safety committees and said, here are the drawings. What do you think? What would you like to see? Where do you want to see certain switches? And I think things that give us clout and respect in our company as far as, okay, they're willing to work with us. This isn't just that we're shoving this technology down their throat, but we're actually trying to work together as a team and ensure the success of the project. And then lastly, I talked about it before, but tabletop exercise, bring in all the stakeholders, run through different SOPs, different processes you do at your various companies, and think about what's the impact of introducing an electric bus? What's a day in the life of an electric bus at your operation like? What are the impacts? Who needs to be notified? What are the SOPs that need to be updated? What kind of help do you need from third-party experts, from OEMs, things of that nature? And that's all I have.
Thank you, Mike. It's great to hear some real-time data and really what's happening on the ground. I'm sure the audience is pretty stoked on what you're sharing there. So we're going to move into questions. I have a few that I'm going to pose, and I'm also going to put forward that question about impacts to city infrastructure, roads. I'll send that to you, Mike, at the end. So if there's questions that are coming to mind for you, I encourage you to line up, and I'll let you know if we're out of time. I'll let you sit down so you're not standing. But maybe you want to stretch your legs. All right, so first question. I'd like each of you to describe an example of when the electrified system performed exactly or better than you had expected. So in Winnipeg, with the pilot program that was going on, Ray, Pierre, you have so much experience internationally. I'm sure you have many examples. And Mike, in the past few months of what's happening with TTC, and from what you just shared, it sounds like you probably have can expand on that. And then, so in addition to sharing when the system performed exactly or better than you expected, and what system conditions were in place that led to that, on the flip, share with us when the system did not perform as you had expected. Ray, I'll start with you.
Is it on?
I don't think so. It's okay. Try again.
This one's working.
Can everyone, Ray, sing us a song. Can we hear you?
I can't sing. You don't want.
No.
It's rugby song.
Rugby song. Yeah, the volume isn't working. It doesn't seem.
Can you hear me now? Okay.
No, is it?
Can you hear? Yeah, there we
Yeah,
go. Okay,
perfect.
all right. So now the technology's working. So as I mentioned, there are 2 phases in the bus project that we had. The phase 1 was the first bus, which was a prototype, and then phase 2 was the 4 pre-production versions. As far as I was aware, like generally the technology worked well as expected. No significant glitches. The only one I was really aware of was once when we were still using the charger when it was on the prototype when the bus was located, the charging station was located at Manitoba Hydro. We disconnected the charging system while the communication systems was upgrading, and it killed the software, right? So basically we had to reprogram it, and that problem was fixed. So that was the only one I was really aware of. When we were doing that we did monitor the batteries for 3 years, and we developed a data analytics tool to do that, to help monitor the reliability and performance of the battery bus during the wintertime, especially, and again, that helped us quite a bit. It was also a tool for predictive maintenance purposes. And as far as the 4 pre-production versions, The only feedback I've heard was there was a little bit of initial apprehension by the drivers or operators about operating electric bus, but after a while they got used to it, and some of the more seasoned operators were actually requesting to drive the electric buses. There was a little bit of range anxiety, I guess, at first, and so people were tended to overcharge the bus. And when we had the charging system at the airport for the while the bus was at the end of the run, I think it was 6 minutes or 7 minutes of charging would give it 2 hours of run time, and that really wasn't an issue. But people got past that. And actually, that's probably not a surprise. When we started working with Mitsubishi Heavy back in 2011, in Tokyo, they had one. And then so on the automotive side, they had one rapid charging system for their vehicles, and even their own staff were hesitant. But as soon as they put in 2 chargers in Tokyo, the range anxiety went away.
Okay.
So.
Perfect. So yeah, I'll just say we're hearing some around software glitches, apprehension from drivers, and of course some learning curves around the charging. Pierre, what do you have to add for us?
A good experience, I think, is it's coming from Europe on massive deployment is the Amsterdam contract. It's because we learn. It was all about what you just said. It was all about the driver's preparation for the handover from diesel to electric with a brand new network. It works when on day one there is nothing to say. And so that's a good thing because it was massive. I mean, when you put on the road 100 buses, it's not as a trial where you have a backup plan. When you have 5 buses on an operation electric, you always have a backup plan. It will be your old diesel 18-year-old, but you can deliver the service, right? I mean, when you have 120, you do not have any backup plan. It's like a light rail. So you need to deliver. And I think that's a very good experience. I could present during 3 hours how we did that, and it was full of, Anne-Marie said, it takes time. I mean, you have to be ready sometimes to delay a little bit because we don't know everything and it's so complicated, but we know the way to do it. We know what we have to explain. We know how to have the driver on board. Driver has an impact on energy consumption by more than 40%. So good driver, bad driver, some driver will never make it to the last terminal if they're not trained properly. It's way more important than with diesel. A bad one, I can give you 2. I can give you I can't name the city, I'm sorry guys, but the first one is when you when you sign a contract and the buses are never delivered, and you have everybody ready for the inaugural 1 week before, yeah, they will come, and you do not have the bus. You have the charging station, you have the software that manages charging station, smart charging, and you never have the bus. That's a kind of a problem, and that delays have some kind of a costs. Second one is that's coming from down under. That's it's not a negative test because I think we learned from that. You said it from the heat. I can tell you that more than 40 degrees, it's not working. It's not working because you have to cool the battery first, and then you have to cool the passenger second, and then your range is about 15 kilometers. And so basically you try to charge 3 hours, you do 15 kilometers, you charge 3 hours. So there is a lot to develop about that. We learn by trying, That's
Perfect.
for me.
That's great. Thank you.
Oh, sorry, yeah.
So for the good, I think I've answered some of those questions in my presentation, but one is really the energy efficiency that we've seen from our first deployments exceeded our expectations, both from modeling and also from our actual commissioning testing that we did in preparation for our initial launch. As far as the bad, I mean, I talked about the challenges that we've had with dispatching buses early on and making sure that they're charged. You're now asking, garage staff, 4 persons now to be monitoring, charging, and really paying attention to the dispatching of buses, which is something that, it's not really part of their job description, I guess, and they have to kind of learn and get used to it because it will be, I guess, moving forward. So that's unique, and I think the other challenge we've had really was on the charging side with commissioning our chargers. Again, it was a challenge to have 2 parallel projects as far as the bus deliveries and having the infrastructure ready in time so that when the bus arrives, you actually have a means of charging it. I mean, that would look really bad if you get a bus and you can't charge it. So luckily, we didn't run into those issues per se, but as far as commissioning chargers, we did run into challenges because when we commissioned the chargers, we didn't use our buses because they weren't available yet. So we're using demo buses, and sometimes demo buses aren't really equivalent to the bus you're receiving. And so we've experienced that from both vendors that we've received already. We've had some minor challenges, but I will say that both vendors did step up to the table, worked with us, and worked hard and relentlessly until the issues were resolved. And so I thank them for that. But yeah, it's something to look out for with the charging as far as commissioning it. It can be challenging.
Great. So a big piece of that, of course, is make sure your buses show up on time and make sure your infrastructure is also there ready to support them. So I have a couple more questions. If there are questions from any of you, please line up, because otherwise I'll just keep going. So my next question, if I had a time machine and you could only use it for this purpose, nothing else, and it will enable you to go back and start over with your deployment or with your program or your project, is there anything that you would do differently or you'd go back with some hindsight? Ray, you can start us off.
I think the first thing we could look at is just be more aware of infrastructure requirements. I'm talking with respect to the charging system itself. We had, as part of the phase 2 project, we had to relocate the charger to the airport. So then, how do we get the land? The cost of doing modifying existing infrastructure, getting power there, the curb cuts, that sort of thing. And there's nothing anybody could have done about this, but our original supplier chose to leave the business, right? So then we had to change,
Okay.
or in the future going forward, we'd have to find another supplier.
Okay. So you just had to really think on your toes there, and the decision was to move
it was okay for the project we had, but going forward, we'd have to find
Okay,
another
so we'll
supplier.
go back in time and we'll make sure they don't leave.
Yeah.
Okay, got it.
And I think another thing that came out of it was I believe the properties are expecting now that the bus manufacturer also is involved with the charging integration into the infrastructure.
Great.
Clearly, nothing. I mean, I mentioned bus not delivered, but if you choose the right provider right now, this is not an issue. I think one thing I would do differently 10 years ago, 5 years ago, is working more on smart charging. I think 5 years ago we were ready to work with an electricity provider on smart charging, so to avoid peaks, to avoid a highly and too heavy dimensioning system. We wanted to charge at maximum a lot of buses instead of thinking about what the bus will do next day. And you do not need to have all the buses at 100%. And that has a massive impact on the balance, on the economical balance. So I would probably focus, if I could travel back, I would probably focus on that. You talk, Ray, about the ground. It's easy to purchase a bus. It's way more complicated to work with 10 organizations when you want to put a fast charging station somewhere in the city. You have the owner of everything under the road. So that's quite complicated. But clearly, smart charging is a key point.
Great.
For me, it's time and resources. Time, which I couldn't really control, even if I could go back in time and change that, because with us, our timeline was really driven by the funding opportunity and really a funding deadline. But resources, I think in the last panel, Dom from TransLink brought up that he worked with a small team and they thought they could do it with a small team, and how Edmonton has an army of people that are working on their program. It was the same at TTC. I mean, we thought that we could do it with the staff we had. We did hire people, but we didn't have the people in the project early enough when we hired them, and then the time to build up that expertise. So if we could get more resources, I think it would have made our lives a lot easier, where we were scrambling, working a lot of hours, off shifts, just trying to maintain that schedule and ensure like a successful deployment.
Okay. So a time machine and maybe a cloning device. I think that would be really helpful for the TTC. So next question I have, and then I'm gonna change gears here. So the previous panelists, some of the previous panelists touched on this a little bit in terms of, more and more city councils across Canada are declaring climate emergencies, and they're adopting really strict climate action plans, of which transportation is often a large part of that, because transportation is usually the biggest source of carbon pollution in cities. Oftentimes councillors want it like that, and they perhaps, as was touched on earlier, don't understand, because they're just like, everyone else, they need to be educated, and they need to have the opportunity to ask questions and receive answers. Because we know that with electrification, an overhaul of our streets and our depot is required. So I'm curious for each of you, is there anything else besides what's been touched on in terms of your experience with council and them wanting the electrification but without the disruption? Do they understand the system overhaul that's needed? Has there been any techniques that have worked for you working with council? Is there anything that any of you would like to add around that?
I can start. So in our case, we didn't actually deal with council on
Right.
on this. This initial project came out of a provincial initiative because they signed an MOU with Mitsubishi Heavy back in 2010 on various areas to work in, of which electrification of transportation was one. But what we did do after the end of the project, of the SDTC project, we had a working group that was put together that included representatives from the city, from transit, from New Flyer, Manitoba Hydro, and ourselves, and developed a plan for electrification of transit, which is actually available on our website. And some of the considerations that we had, which I presume were reflecting, transits and the city's needs, which were probably driven by council, would be things like, the routing was a significant factor, like the route itself, where would we put the charging systems? It was important to integrate with the existing diesel fleet, which I think there's about 550 buses right now in the city, and I believe, and I'm just going by memory now, and transit could confirm, but I think during rush hour, where like 500 of them are on the road, right? And then my sense was if we could have done charging on the go versus having charging systems, we might have accelerated that uptake on them. We actually did start a follow-on project with the support of New Flyer and NSERC to look at actually on-the-go charging. It was going to be, and there was Western diversification support in there as well through an initiative that they had, and they had University of Manitoba involved as well. It was basically a Chevy Volt on steroids, right? So phase 1 was proof of concept, phase 2 was a prototype, phase 3 would have been testing. And we made it to the end of phase 1 because we were going to use a gasoline-powered, carb-compliant engine to do the charging of the battery packs. And then the supplier decided to not pursue that business. So the project stopped there.
All right, so a little bit of a mixture of the choice of infrastructure used for charging, but also the importance of convening with working groups, which works whether you're dealing with city council or provincial, just being able to bring together the stakeholders to share the messages and work through any questions or issues. Pierre, anything to add from the political perspective?
Yeah, I think, I wouldn't say everything is about the money, but when we talk about electricity, we talk about costs. We all have in mind the climate change. We have that, but it has been said before, right? I mean, when you go to the bottom line, and councils, politicians, they have that in mind. I think one of the things we need to think collectively is how do we induct patronage, more passenger on buses because we are green? What will be the effect for everyone taking care of this planet and people taking cars will say, oh, because the transit is going green, I'm going to take the bus. Of course, you need to have the bus. You need to have the passenger capacity and not only 20 or 30 or 40 passenger per bus. So it has to be taken into account in the economical balance because unless you're a free operator, people pay to take your bus. If you put more people on the bus because you're green, then it's not only changing from diesel to electric, there is something else here. And last thing is talking about the global impact. If you talk to a councillor, if you talk to a minister, people are also in charge of health. It was said by Anne-Marie before. There is a study done in New York about the cost of changing all the buses in New York City to electric. It has been done, I think, in 2016. You can find that in the internet. It's controversial because it says it paid by himself by reducing the healthcare costs. But when they say healthcare cost, of course it's over 30 years because it's lumps issue. You don't cure in 5 days from something you suffer. But they say it will, it's free. Doing electric transport even now is free. The problem is who will take the risks. Mm-hmm. So you need to, in my point of view, to convince people and to be better, you need to lock what you know. And there is some stuff we don't know, but some stuff we know, and to take into account a wider scope that only I will switch my diesel bus to an electric one. Otherwise, we won't convince and we won't be good at that.
Okay, great.
So I think councillors, again, they're busy. They have many different things that they have to deal with. So I don't expect them to be experts by any means on electric buses and deployment strategies. But I think maybe we need to do a better job educating them. And to me, I see the challenge really here is brownfield construction versus greenfield construction. It's completely different. And people all the time say, well, in Asia, they got 100,000 buses running. Well, yeah, but those are all greenfield construction, that purposely built facilities that aren't constrained by our parking nose to tail in a barn, have brand new routes that are developed around that technology, where we're trying to integrate to something that already exists, where we don't have real estate space in all locations. You know, we might have a transformer station that's a kilometer away or maybe 15 kilometers away. There's lots of challenges here, and what that means time and money. And councillors don't necessarily understand that, because they're looking at, you know, ribbon cutting events and you know, patting themselves on the back saying, hey, you know, we beat out that other city, we have a bigger fleet than they do. But the timing and the expectation times aren't realistic. And so it's just a matter of us educating them so they understand really what are the challenges here with adopting this technology, and what are the risks associated with it. It's not all about just that day that we cut the ribbon and say, here, buses going into service. There's a lot of work that goes into getting to that day that they don't really understand.
I used to work in municipal government, so I can echo some of what you're saying there. I'm going to remove my question I had. I'm going to ask the question around the weight of the battery, and then there was an individual over there who I think still may have a question, but Mike, and then maybe Pierre, you can add to this. The question earlier was talking about the weight of electric buses because of the batteries. Curious if the TTC did any projecting on the wear and tear, or you know, what the expected road impacts will be, or you know, any commentary around that?
The short answer is no. I think we're within the limits in our jurisdiction. I think there's different limits depending on the province. I know in the province of Ontario, we're within those limits. I will say that just from, you know, driving, and I grew up in Toronto, you can definitely see that there is wear and tear on the road just from our existing fleet. I'm not sure if an extra 2,000 pounds will make that much of a difference. Hard to say. To me, it's not so much the weight of the bus on the roads, but rather the weight of the bus with the batteries and what that does to passenger counts and passenger loading, which is something that the industry needs to look at and look for means, whether it be through you know, battery density improvements or then axle upgrades to ensure that we're within those axle limits.
Great. Pierre?
For those who were in Quebec last winter, we were obliged to stop half of our hybrid buses because regulation limit during the, I don't know how you call that, de-icing period in May or April. With 10 passengers on board, we were overweight. And Montreal had to stop during one day till the minister changed the law. Nobody noticed that for the last 20 years, by the way. So I think we are not heavier with electrics than hybrid. Hybrid was a combination of the worst because you have all the diesel, very heavy, and all the electric. I agree with you. I think it's also what is the impact of the buses on the road versus the trucks. I mean, really, buses will have that impact versus all the delivery truck of the big or small trucks. So I think it's marginal. Still, there is a weight limit that nobody will cross. So under this limit, roads are supposed to last a certain period of time. Coming from Quebec and Montreal, I won't tell about the road condition here.
Great.
It's famous worldwide.
Was that question still out there? I think it is. Thank you.
For Mike specifically, how did you gather the data for your presentation?
So all our buses are equipped with a Versity telematics system. So we have real-time monitoring of our buses. We can download all the information from the CAN bus as far as energy consumption, all the various systems, faults on board, charging events. And we do know that all three buses will be equipped with their own telematics from the OEM. So in the case for our Flyer bus, New Flyer also put their Connect system. So they're also in the background monitoring and sending us regular reports on the bus performance, which we then compare to ours. And for the most part, they do correlate, which is good. But yeah, we basically equipped all three buses with a third-party telematics system so that when we're reporting data, it's all from the same type of system, same source, so no one can dispute it and say that anybody's been fudging numbers or inflating numbers or editing.
Thanks.
Great. Go right ahead.
Just one question regarding the difference of charging types, the plug-in charger versus the overhead charger. I have the impression that the plug-in chargers must be a lot less capital cost than the overhead chargers. My understanding is that Electrify America, the Volkswagen recent capitalized company, has just installed 2,000 fast chargers at less than $200,000 US per site. And I'm just wondering, maybe a company with that expertise doing such high volume installations around the US may have some value to add as a consortium partner to bring the costs of charger installations down, because the utilities and the transit agencies, neither of them have a volume approach to charger installation. So just a thought whether 200,000 US per charger installation is way below where you guys are seeing the numbers.
No, the chargers we procured were less than 200,000. So I don't know as far as Volkswagen if that's truly a deal, but I do agree that scale of economies. I think that if we buy more chargers, we can definitely drive down the price. And I want to know how many chargers we need to buy so it's free. But I'm not sure we'll ever get to that point. But definitely, if we're buying more chargers, the price should go down.
Pierre, you chuckled.
I mean, from my memory, there is a limitation on the amount of power you can transfer by a plug-in that you do not have on a reverse or pantograph. So we usually use this technology for very, very fast charge of very high density of energy. I think the cost of a charger is not really the pantograph itself, it's also technology behind that to convert the current and to prepare the energy to be transferred. It's not the technology of pantograph. I mean, how many trains have pantograph in the world? I mean, it's very reliable and not, I wouldn't say cheap, but it's not very expensive. So the whole lot is about the charger itself and the cabinet in which it sits, and whatever technology you choose, that's where the money sits.
Okay. I've got another question, and then if someone does, actually you can go right ahead. More exciting to hear from the audience. It could be you next.
All right. So we know that we have done the modeling for at least for TTC as part of Qtrig, but I want to know what is the different amount of the kilowatt hour of the battery usage when the ridership is at the highest and when it is lowest. So what's the difference? Have you guys calculated that? Have you seen that? And what is in the moderate scenario, maybe, which is the regular average usage?
Sure. So the average energy consumption I had in my presentation, I recall, I think it was 1.55 for the month of August, and I think that's slightly inflated based on activities that we were doing with commissioning buses and whatnot. It's hard to say. The peaks would be in one of the slides too, where I have the energy consumption over time of day, where you see peaks in the afternoon. I don't know what that would have been like, but if I had to guess, it'd probably be over 2 kilowatts per kilometer, I would think, at those peak stages. But those instances where we're crush loading buses are typically only for like a 10, 15-minute interval. So it's for the period that the bus is in service, it's actually a very short period of time where you see those really high loadings from passengers.
I mean, interesting question, because we never thought about that when we were running in diesel. Nobody asked me beginning of the 20,000, how much do you use when you're full loaded versus half loaded? Because we had an average, let's say 50 liter per 100. For my figures, without trying to have not the impact of the climate, because morning, afternoon in August, but you will have that very quick now in mid-season, it's about, let's say, 20%. But we are not full all the time in transit. You're full during, let's say, an hour and a half, and then you're a bit less full, and then you're a bit empty, depending on your schedule. So that's why we work in average. We just want to reach the end. But yeah, about 20%, which is roughly, I say roughly the same as diesel.
Okay. So last question I'm just going to pose. Mike, you touched on this a bit earlier in terms of talking about the design of an electric bus. So often feedback that is coming in from drivers is that it provides for a smoother ride and it's quieter. Wondering if you're, for all of you, Ray, I'll start with you actually from the pilot. Haven't been many questions to you, I don't want you to feel left out. So in terms of what kind of feedback was there? Is there anything that was shared with OEMs, or is there anything that could be shared for Pierre and Mike in terms of improving that aesthetic swank factor?
Yeah. I don't think we can overlook the heating cooling requirements versus the attractive energy requirements. And I think we found, at least with a prototype, we needed, for every unit of energy to move the bus, we needed 5 at temperature extremes to heat it or cool it.
Okay.
Because we do have an extreme climate here.
Yep.
We're actually colder than Mars in the wintertime.
Good to know.
And I guess the other, I'll have a few ideas here, but the other one, 2 others I'll just quickly mention. So on the auxiliary heating, we're actually talking with a European company with a thermal battery technology, which uses phase change to maybe do that initial cabin heating before the bus goes out on the road. So we're looking at that. The other thing I mentioned during my presentation was about the repurposing of batteries. after they've done their useful life in the bus, because there will also be a related disposal issue down the road, right?
Okay, great.
Feedback on electric buses from the driver's point of view, some of them are too quiet, so they hear too much the passengers. That was not expected. You know, everybody wants a quiet bus, but you know what? No, you don't really want. Sometimes you prefer to hear a loud, very rough noise of an engine that covers the noise of everybody's talking on the bus. So that's a funny one. Yeah, indeed. And sometimes the air conditioning is very noisy. I mean, you hear some stuff you never heard before. That's the feedback from the driver. My point is, I think OEM in the future need to be a bit more innovative, because thanks to electricity, they do not have the same constraints in the way the bus is built. They have way more margin on the way to reorganize how passenger flow is into a bus, because you do not have those constraints we had for the last 50 years. So that will be that is already, when I discuss with them, some things I need to think about it.
Okay. Last words from Mike.
So the engineer in me thinks that now that you have electric buses and electric propulsion systems, you got rid of that diesel engine, you got rid of the transmission, there's lots of space in that rear of the bus. And with in-wheel traction motors, to me, it brings up opportunities to have a fully low-floor bus from front to rear instead of having that upper deck. And I think that would be something that the public would like. And possibly configurations for door placements, exit doors. The operator in me, although I'm not an operator, I think they all want more visibility. So smaller, narrower A-pillars and more glass, more visibility. And for passengers, what I see, we, and 2 years ago, started equipping our buses with USB ports. Something so simple, but it's unbelievable how people love USB ports, and all they talk about is how great it is. And so to me, it's, sometimes it's just those quick wins, easy wins. And so there's got to be something else we could look at as far as maybe real-time GPS tracking so that the passengers know where they are, or we have infotainment screens on our buses now. Leverage those screens so we can maybe advertise how much GHG we avoided in your trip. So if you get on the bus, you could see, okay, well, I was on the bus for 5 minutes and I avoided 15 kilograms of CO2. Things of that nature, I think, to keep the public aware and, I guess, excited about the new technology.
I think that's awesome in terms of the education piece, a bit of a living lab with them. But then also the USB ports keep people distracted. That could help Pierre with, drivers not wanting to hear the conversations that are happening. Though that could end to more FaceTime conversations, so I'm not sure. Okay, so I believe I'm out of time. Yes, I am. Okay, so thank you to Ray, Pierre, and Mike for sharing your experiences and your lessons learned, and I hope all of you enjoyed that. Thank you.